What if you could stand beneath a sky where Saturn's radiant rings stretched out like a cosmic masterpiece above your head? A place where moons larger than planets cast shadows over alien oceans, and the air hums with mysteries yet to be uncovered. Saturn, the jewel of our solar system, has captured human imagination for centuries with its beauty and enigma. But here's a thought: what if the dream of reaching it wasn't confined to science fiction anymore? Imagine a future where traveling to this distant world is as attainable as crossing continents once felt to early explorers. How long would it take us to get there? What would it mean for humanity to take such a bold leap into the cosmos? In this video, we will unravel the answers, exploring not only the cutting-edge technologies that could reshape space travel, but also what life might look like on such a journey. The possibilities are as vast as the universe itself, so get ready to embark on a journey beyond anything you've ever dreamed. Now turning to the breathtaking majesty of Saturn itself, this celestial giant is nothing short of mesmerizing. Saturn, the second largest planet in our solar system, sits about 1,200,000,000 kilometers away from Earth, a distance so vast it stretches the imagination. Its iconic rings, a dazzling array of ice and rock particles, encircle the planet like a masterpiece crafted by the universe itself, reflecting sunlight in a display that has enchanted sky watchers for centuries. These rings are not just beautiful, they are also scientifically fascinating, offering clues about the formation of our solar system. But Saturn's wonders do not stop there. With over 80 moons, Saturn feels like a solar system of its own. Among these is Titan, a world larger than the planet Mercury, boasting a dense atmosphere and lakes of liquid methane that hint at conditions unlike anywhere else in the solar system. Imagine standing on Titan's surface where the hazy orange skies never clear, and the possibility of alien chemistry fuels endless curiosity. Since ancient times, Saturn has been a symbol of mystery and grandeur, featuring prominently in mythology as the god of time. In modern science, it represents the frontier of exploration, a place that challenges us to keep reaching further. To journey to Saturn is to push the boundaries of what we know, to chase an ambition as timeless and infinite as the cosmos itself. This allure, blending beauty, scale, and mystery, makes Saturn not just a destination, but a dream worth pursuing. Now turning to the methods humanity has relied on to explore the cosmos, the traditional technologies of space travel tell a story of monumental achievements and persistent limitations. Take, for example, the rockets of the Apollo era that carried astronauts to the moon. These spacecraft were marvels of engineering but were designed for journeys measured in days, not years. Even the more advanced technologies of today, such as NASA Cassini spacecraft, which provided groundbreaking insights into Saturn, reveal the challenges we face. Cassini's journey to Saturn took 7 years, a timeline that underscores the immense distances involved and the constraints of current propulsion systems. These systems rely heavily on chemical rockets, which, although powerful at launch, consume enormous amounts of fuel for relatively short bursts of speed. This approach works well for reaching nearby destinations like the Moon or Mars, but the vast expanse between Earth and Saturn demands a different level of efficiency and endurance. Slow speeds and limited fuel storage become serious obstacles, making it clear that our current methods are simply not optimized for such long-haul interplanetary journeys. To make Saturn a realistic destination within a human lifetime, we need propulsion technologies that not only maximize speed but also conserve resources, paving the way for revolutionary advancements in space travel. The need for innovation has never been more urgent, and it raises a compelling question: how might future technologies transform this dream into reality? Moving forward, let us dive into the fascinating physics that governs space travel to Saturn. At its core, any journey into the cosmos begins with achieving escape velocity. This is the minimum speed required for a spacecraft to break free from Earth's gravitational pull, which is roughly 40,000 kilometers per hour. Once free of Earth's grip, the challenge shifts to navigating the vast distances of space efficiently. This is where orbital mechanics comes into play. Instead of traveling in a straight line, spacecraft follow curved trajectories or orbits influenced by the gravitational forces of celestial bodies. These trajectories must be meticulously planned to ensure the spacecraft reaches its destination with precision. A particularly ingenious technique often used is called a gravitational slingshot. This method involves steering the spacecraft near a planet or moon to harness its gravity as a kind of cosmic boost. For instance, by passing close to Jupiter, the immense gravitational pull of this gas giant can accelerate a spacecraft to much higher speeds while conserving its own fuel. This technique was famously employed by the Cassini spacecraft during its journey to Saturn, significantly reducing the time and energy required for the trip. However, plotting such a journey is no simple task. It requires calculating complex equations to account for the movement of both the spacecraft and the planets, as well as their ever-changing positions in space. Timing becomes everything in this cosmic dance, as launching even a day too early or too late could drastically alter the mission's success. The sheer vastness of space adds another layer of complexity. Covering a distance of 1.2 billion kilometers to Saturn means ensuring that every maneuver is precisely executed and that the spacecraft is equipped to sustain itself for years. These challenges illustrate just how much brainpower and ingenuity are involved in making such a journey possible. But while traditional physics has paved the way for our current capabilities, the future may hold even more groundbreaking solutions that build on these principles. As we look ahead, the question now becomes, how can advanced propulsion systems bring us closer to Saturn faster than ever before? Now turning to the historical achievements that have brought us closer to understanding the journey to Saturn, one cannot overlook the remarkable mission of the Cassini spacecraft. Launched in the autumn of 1997, this groundbreaking mission took approximately 7 years to reach Saturn, finally arriving in the summer of 2004. The journey was anything but straightforward. After leaving Earth, Cassini first traveled to Venus, performing not one but 2 gravitational slingshots around the planet to gain speed. It then returned to Earth's vicinity for another gravity assist before making its way past Jupiter, where it picked up its final boost. This carefully orchestrated path was necessary to conserve as much fuel as possible while still covering the immense distance of 1.2 billion kilometers. To put this into perspective, the 7-year timeline included nearly 4 billion kilometers of total travel due to the intricacies of its trajectory. Each leg of the journey was meticulously planned, taking into account the positions and gravitational influences of various celestial bodies at precise moments in time. When Cassini finally reached Saturn, it became the first spacecraft to orbit the planet, marking a monumental milestone in space exploration. Its mission would go on to deliver some of the most stunning images and invaluable data about Saturn, its rings and its moons, transforming our understanding of the outer solar system. While Cassini's success was extraordinary, its lengthy travel time highlights the current limitations of traditional spacecraft propulsion systems. Spending 7 years in space requires an incredible amount of resources, planning, and onboard durability. This reality underscores the pressing need for advancements in technology that could significantly shorten travel times for future missions. As we consider the awe-inspiring achievements of past explorers, it becomes clear just how much room there is to innovate and push these boundaries even further. With that in mind, the spotlight now shifts to the exciting realm of futuristic propulsion systems that have the potential to revolutionize our journey to Saturn and beyond. With the next phase of the journey in sight, we venture into the fascinating world of futuristic propulsion systems, technologies that could redefine how humanity explores the cosmos. Unlike traditional rocket engines, which rely on chemical fuel to produce a powerful but short-lived thrust, these advanced systems aim to combine efficiency and speed in ways never before possible. Take ion propulsion, for example. This technology uses electrical energy to ionize a gas, typically xenon, creating charged particles that are expelled at incredibly high speeds to generate thrust. While the thrust produced is relatively small, it is continuous, allowing spacecraft to gradually build up to extraordinary velocities over long periods. This means that a journey to Saturn, which currently takes years, could potentially be cut down significantly with a sustained and efficient system like this. Then there is nuclear thermal propulsion, a method that uses a nuclear reactor to superheat a propellant such as hydrogen and expel it to create thrust. The advantage here lies in its ability to provide far greater thrust than ion propulsion, making it ideal for missions requiring quicker acceleration. Imagine a spacecraft equipped with this technology reaching the outer planets in a fraction of the time it currently takes. Another promising area is electric propulsion, which involves harnessing solar energy or nuclear power to drive highly efficient thrusters. This technology has already been used successfully in missions closer to Earth, and its potential for deep space exploration is immense. As these systems continue to evolve, experts predict that we could see their implementation in interplanetary missions within the next few decades. The combination of faster acceleration and better fuel efficiency could revolutionize how we think about space travel, making the dream of reaching Saturn not just a technological possibility but a practical reality. These groundbreaking advancements are not only about speed, they represent a major leap forward in sustainability and resource management for long-duration missions. With such systems on the horizon, the obstacles that once seemed insurmountable in space exploration are now transforming into achievable milestones. While these propulsion technologies hold promise for significantly reducing travel times, the question remains, what would it be like for humans to live and work aboard such advanced spacecraft on a journey to Saturn? Now turning to the next frontier in propulsion technology, fusion propulsion emerges as a groundbreaking possibility that could redefine the future of interplanetary travel. Unlike traditional or even other advanced propulsion systems, fusion propulsion draws its immense power from the same process that fuels the stars. By using hydrogen isotopes, specifically deuterium and tritium, fusion reactions create an extraordinary amount of energy by combining these particles under intense heat and pressure. The result is not only a massive release of energy, but also the emission of charged particles that can be harnessed to generate thrust. What makes fusion propulsion so revolutionary is its potential to deliver unprecedented speeds. With the sheer energy output of fusion, spacecraft could theoretically reach velocities far beyond those achievable by current technologies. This means that what now takes years to accomplish, such as a journey to Saturn, could be reduced to just a few months, bringing the dream of swift interplanetary travel within reach. Experts in the field are optimistic about the future of fusion propulsion, with promising research projects already underway. For example, experimental reactors on Earth, such as those being developed for energy production, are providing valuable insights into how fusion could be adapted for space propulsion. Although significant hurdles remain, such as maintaining stable reactions and creating compact systems suitable for spacecraft, advancements in these areas are accelerating. Many scientists believe that with continued investment and innovation, we could witness the deployment of fusion propulsion systems within the next few decades. Beyond speed, fusion propulsion also offers remarkable advantages in efficiency and sustainability. The fuel required for fusion, derived from hydrogen, is relatively abundant and would produce minimal harmful byproducts, making it an environmentally friendly option for long-duration missions. Imagine a spacecraft capable of carrying humans to the outer planets at record speeds, equipped with a propulsion system that minimizes waste and maximizes energy efficiency. As research continues to push the boundaries of what is possible, fusion propulsion stands out as a beacon of hope for overcoming the vast distances that separate us from the far reaches of our solar system. With this revolutionary technology on the horizon, humanity is one step closer to making journeys to Saturn and beyond not just feasible, but also practical and efficient. While fusion propulsion offers an exciting glimpse into the future of space travel, it also raises an important question. What would it take to ensure humans can endure and thrive on such lengthy and ambitious missions? As the next challenge unfolds, living and traveling in space brings a host of unique obstacles that astronauts must overcome, especially on a journey as long as the one to Saturn. One of the most pressing concerns is radiation exposure. Unlike life on Earth, where our planet's atmosphere and magnetic field serve as natural shields, space travelers are exposed to harmful cosmic rays and solar radiation. Extended periods without adequate protection could increase the risk of cancer or other health complications. To counter this, researchers are exploring advanced shielding technologies, such as specialized materials that can block or absorb radiation, as well as innovative concepts like magnetic fields artificially generated around the spacecraft to mimic Earth's defenses. Another critical challenge is the effect of prolonged weightlessness on the human body. Without gravity, astronauts experience muscle atrophy and bone density loss, which can significantly weaken their physical condition over time. To address this, space agencies are developing artificial gravity systems, where the spacecraft could rotate to simulate gravity through centrifugal force. Additionally, rigorous exercise regimes using resistance machines and treadmills designed for zero-gravity environments help combat these effects, ensuring that astronauts maintain their strength for the duration of the mission and upon arrival at their destination. Equally important are the psychological hurdles that come with living in confined spaces for months or even years. The isolation, lack of natural sunlight, and limited social interaction can take a toll on mental health. To tackle these issues, experts are creating virtual reality environments that allow astronauts to explore simulated Earth-like settings, such as forests or beaches, providing a much-needed escape from the monotony of their surroundings. Advanced communication systems are also being developed to improve connectivity with loved ones back home, helping maintain emotional well-being. In addition to physical and mental health, proper nutrition plays a vital role in long-term missions. Scientists are working on growing fresh produce in space using hydroponic and aeroponic farming techniques, enabling astronauts to cultivate fruits and vegetables even in the barren environment of deep space. This not only ensures a steady supply of nutritious food, but also introduces an element of variety and comfort, improving morale. Imagine astronauts harvesting their own crops while millions of kilometers away from Earth, a small but meaningful reminder of home. These futuristic solutions paint an inspiring picture of how humanity could adapt to the challenges of interplanetary travel. They illustrate how innovation and creativity are paving the way for comfortable and sustainable life during extended space missions. Navigating these challenges is an essential step in making the dream of reaching Saturn a reality. But what if technology itself could redefine how we approach these journeys, even taking on roles we never thought possible? Now turning to the transformative role of artificial intelligence and robotics, these groundbreaking technologies could redefine how we approach the monumental task of traveling to Saturn. Artificial intelligence, with its ability to process vast amounts of data in real time, could revolutionize navigation by calculating the most efficient routes, adjusting trajectories mid-journey, and conserving precious resources like fuel. Imagine a spacecraft equipped with intelligent systems that can autonomously detect and avoid potential hazards, such as asteroid fields or unexpected debris, ensuring a safer passage through the vast expanse of space. Beyond navigation, artificial intelligence could also manage spacecraft systems, monitoring everything from power levels to life support systems, identifying issues instantly, and even initiating repairs without human intervention. We already see examples of these capabilities in action today. The Perseverance rover, currently exploring the surface of Mars, operates with advanced artificial intelligence to make independent decisions, navigate challenging terrains, and conduct experiments. This serves as a glimpse into how similar technologies could be adapted for Saturn missions, where the stakes, distances, and complexities are far greater. Robotic systems, on the other hand, could take on tasks that would prove too dangerous or strenuous for human astronauts. From setting up pre-human habitats to mining resources on Saturn's moons, robotics could act as pioneers, preparing the groundwork for eventual human arrival. Furthermore, artificial intelligence could play a critical role in predicting and responding to unforeseen challenges during the mission. For instance, if a spacecraft encounters mechanical issues millions of kilometers away from Earth, advanced artificial intelligence could troubleshoot the problem, suggesting solutions or deploying robotic units to carry out repairs in real time. This self-sufficiency becomes invaluable as communication delays grow due to the immense distance between Earth and Saturn, making immediate human intervention impossible. The synergy between artificial intelligence and robotics could also enhance the safety and efficiency of deep space exploration. Imagine robotic probes sent ahead of human missions to analyze Saturn's environment, mapping potential hazards, and gathering crucial data about conditions on its moons, such as Titan. This data could not only guide mission planning, but also enable astronauts to focus on exploration and discovery rather than survival. By leveraging these technologies, we are not merely making Saturn missions feasible. We are fundamentally rethinking how we approach the challenges of interplanetary travel. As artificial intelligence and robotics continue to evolve, they promise to act not just as tools but as indispensable partners in our quest to explore the outer reaches of the solar system. With their potential to handle the complexities and uncertainties of space travel, they pave the way for humans to boldly venture farther than ever before. But technology alone is not enough. Making these ambitious journeys a reality also requires the collaboration of visionaries across the globe. This brings us to the vital role of space agencies and private companies in shaping the future of interstellar exploration. Moving forward, the collaboration between major space agencies and private companies represents a powerful catalyst for making the journey to Saturn a reality. Government agencies such as NASA play a pivotal role in laying the scientific and technological groundwork for interplanetary exploration. Take NASA Artemis program, for instance. While its current focus is on returning humans to the Moon and preparing for missions to Mars, the technologies being developed, like advanced propulsion systems and sustainable life support, could easily be adapted for the far greater challenge of reaching Saturn. Meanwhile, private companies like SpaceX are pushing boundaries in ways that were once unimaginable. SpaceX's ambition to colonize Mars has already spurred significant advancements in reusable rocket technology, which dramatically lowers the cost of launching payloads into space. These innovations could serve as stepping stones toward enabling missions to destinations even farther afield, such as Saturn. But it is not just about individual efforts. The real game changer lies in partnerships between public and private entities. Imagine a future where government-funded research combines with the efficiency and ingenuity of private industry. Such collaborations could accelerate the development of next-generation spacecraft capable of overcoming the immense technical challenges posed by the vast distances and hostile environments of deep space. For example, NASA could focus on long-term scientific goals and infrastructure, while private companies provide faster, more cost-effective solutions for manufacturing and testing spacecraft components. Together, these entities could pool resources, knowledge, and expertise to achieve breakthroughs far more rapidly than either could alone. Funding also plays a crucial role in driving these efforts forward. Ambitious missions to Saturn require significant investment, spanning years or even decades of research and development. Public funding, buoyed by political will and the support of taxpayers, is essential for sustaining the foundational science and exploration goals that benefit humanity as a whole. However, private investment adds another layer of dynamism, often driven by commercial interests such as resource mining, tourism, or technological spin-offs. This dual-stream funding model can create a more resilient ecosystem for space exploration, reducing the dependency on any single source and spreading the risk across multiple stakeholders. Public interest and enthusiasm are equally vital. High-profile achievements like the first crewed mission to Mars or the establishment of a permanent lunar base can inspire global excitement and support for space exploration. This public enthusiasm often translates into political momentum, unlocking additional funding and resources. Moreover, the shared dream of exploring beyond Earth has the power to unite people worldwide, fostering international collaboration and partnerships that are crucial for tackling the monumental task of reaching Saturn. Countries could contribute unique capabilities, whether through technology, funding, or expertise, creating a collective effort that transcends borders. By mobilizing the combined strengths of governments, private companies, and the public, humanity can overcome the seemingly insurmountable challenges of interplanetary travel. The journey to Saturn is not just a test of our technological prowess, but also a testament to our ability to dream big and work together. Yet, as we advance toward this goal, it is worth asking what impact would such an achievement have on Earth itself? What economic, societal, and cultural transformations could we expect as a direct result of reaching one of the most iconic planets in our solar system? As the next challenge unfolds, the implications of reaching Saturn stretch far beyond the act of simply planting a flag or conducting scientific experiments. Imagine tapping into the untold resources hidden within its moons or even its iconic rings. Saturn's largest moon, Titan, is particularly intriguing. With its dense atmosphere and lakes of methane, it could serve as a treasure trove of hydrocarbons, potentially revolutionizing how we think about energy resources. While such an endeavor is still speculative, the possibilities could redefine industries on Earth, sparking innovations in resource extraction, energy production, and even environmental sustainability. Commercial mining missions, once a hallmark of science fiction, could become a cornerstone of our interplanetary economy, providing materials that are scarce or inaccessible on Earth. But the impact of reaching Saturn does not stop at resources. The idea of establishing permanent settlements in the outer solar system pushes the boundaries of human ambition. Imagine entire colonies thriving on Titan or Enceladus, equipped with advanced life support systems and self-sustaining habitats. These settlements could serve as stepping stones for even deeper space exploration, creating an entirely new chapter in the history of human expansion. Such achievements would require unprecedented advancements in technology and engineering, driving innovation that would undoubtedly trickle down to benefit life on Earth. For example, developing systems to sustain life in the harsh conditions of deep space could lead to breakthroughs in renewable energy, water purification, and food production technologies that could significantly improve life in remote or resource-scarce areas on our home planet. The cultural ripple effects would be equally profound. Reaching Saturn would symbolize humanity's ability to transcend boundaries, unite for a common goal, and achieve something monumental as a species. This could inspire a new wave of art, literature, and philosophy, centered around themes of exploration, resilience, and universal interconnectedness. Schools might incorporate space travel into their curriculum at an early age, fostering a generation of problem solvers inspired by the challenges of interplanetary life. Movies, books, and other forms of entertainment could shift their focus to stories of human triumph in the outer solar system, sparking imaginations worldwide. On a broader societal level, making space travel to Saturn more accessible could democratize exploration itself. Programs designed to include people from diverse backgrounds, regions, and disciplines could ensure that the benefits and opportunities of space exploration are shared more equitably. By placing humanity's collective achievements at the forefront, such a mission could also foster international cooperation on Earth, encouraging countries to work together on other pressing global challenges such as climate change, poverty, and inequality. Ultimately, the economic, societal, and cultural transformations sparked by reaching Saturn could ripple across generations, shaping the trajectory of human progress in ways we can only begin to imagine. The journey to Saturn would not just redefine what is possible in space, but also what is possible here on Earth. This raises a fascinating question: how do we prepare ourselves, both technologically and emotionally, for the immense task of living and traveling in space for extended periods? As we bring our journey to a close, let's reflect on the incredible mix of challenges and opportunities that the prospect of traveling to Saturn represents. From the mind-boggling distances involved to the revolutionary technologies that could take us there, it's clear that this endeavor is far more than just a scientific milestone. It's a testament to human ingenuity and ambition. We've explored the potential of advanced propulsion systems like fusion technology, envisioned life on Saturn's moons like Titan with its rich potential for resources, and considered the profound economic, societal, and cultural shifts that interplanetary travel could ignite. Each step toward Saturn represents not just progress in space exploration, but also advancements that could transform life on Earth, from groundbreaking technologies to a renewed sense of global unity. But ultimately, this journey isn't just about science or technology. It's about our ability to dream, to innovate, and to collaborate on a scale that transcends borders and generations. So, what do you imagine space travel to Saturn would look like? Do you think we'll see colonies thriving on Titan in our lifetimes, or even interplanetary mining reshaping industries back on Earth? Share your thoughts in the comments, and let's start a conversation about the future of humanity in space. Don't forget to like this video, subscribe to the channel, and hit the notification bell to stay updated on more exciting explorations of futuristic technologies and lifestyles. Together, let's keep dreaming big and reaching for the stars.